Hello, I'm Christian Acuna, and working with Sean Mulvihill and Lauren Stark, we did our final systems project on studying the system from an automotive electronic stability control unit. So for some background, we wanted to go over what electronic stability control, or ESC, is. And what ESC is a system within a car where it can correct handling faster and more efficiently and more correctly than a human can. So in the event of a car starting to oversteer, it can apply the brakes individually to each wheel to make sure that the car does not over-rotate and potentially cause a crash and injury to not only the driver, but those driving around them. It does that through a system of logic and sensors, both sensing wheel speed using the ABS system that's already installed on cars, and it also uses a yaw sensor within the car to determine whether it is rotating more than it is supposed to get around a turn. This system can be run almost entirely mechanically, and it is actually now mandated for all new cars sold within the United States as of 2011.
Here we have the block diagram for the electronic stability control system. The reference is the driver input omega. The controller is the engine torque controller and brake torque controller. The plant is the engine and ABS pump. Then we have sensors which act as another input for wheel speed and yaw. The feedback is the vehicle model. The error is our ideal omega minus our actual omega. And our actuators are the ABS and ECU. The disturbance is our throttle pedal, and our output would be our corrected omega. Here we have the block diagram of our vehicle model subsystem, where we go into more depth about what our feedback system looks like.
The understeer gradient, or K, is equal to mg times 1 minus the rear weight bias of the car times the maximum slip angle of the tire over mu front times normal force front. This is subtracted by the rear weight bias of the car times the alpha max of the rear tires, multiplied by mu rear times normal force rear. Omega, or yaw rate, is equal to delta times velocity times 1 over 57.3 times the wheelbase of the car plus k times v squared over g.
This type of control system is a fuzzy logic control system. So why are we using fuzzy logic? Fuzzy logic takes into account multiple inputs, and instead of a Boolean method, which is just 0, 1, or true or false, we can take into values from a range of 0 to 1. So you can see in this diagram here that instead of slow and fast, we have slowest, slow, fast, and fastest. So we get a wider range of outputs. This allows us to apply varying pressures to the brakes.
ESC systems have had considerable impact on the safety of today's vehicles. According to the IIHS, since the implementation of ESC systems, they have witnessed a reduction of single vehicle fatalities by 56%, and all single vehicle accidents, both fatal and non-fatal, were reduced by 41%. Multiple vehicle accident fatalities were less affected and only reduced by 17%. The lesser impact on multiple vehicle accident fatalities is most likely due to the fact that ESC systems mainly prevent crashes where the driver loses control of the vehicle. This is usually due to bad road conditions or excessive speed in corners.
Alright, that's going to do it for our presentation. On behalf of Sean, Lauren, and myself, I want to thank you for taking the time to listen.